Now I need to repair this inverter, and the model is VM3 5 kilowatt. Okay, I don't touching that user, don't worry. Model name VM3 5 kilowatt, color white and black, operating temperature range -10 to 50 degrees centigrade, rated power 5000 VR 500 watts, DC input voltage is 48 volts, DC 118 amps, AC output 230 volt, AC 50 to 60 hertz, 22 amps, power factor 1, AC charger mode, input 230 volt, AC 50 60 hertz, 35 amps, power factor 1, DC output 54 volt, DC mix 60 amps, default 30 amps, AC output 230 volt, AC 50 60 hertz, 22 amps, power factor 1, solar charger mode, rated power 5000 watts, nominal operating voltage is 320 volt DC, maximum solar voltage is VOC voltage open circuit 500 volt DC, MPPT voltage range 120 to 440 volts DC. That's okay. And you don't have LCD to know about the fault. We have no LCD and this inverter. Okay, but we can troubleshoot this without LCD because we know about the topologies and schematics and knowledge for every section. Okay, now I am just providing the power supply to this inverter. Okay, to check the fault, but we have not LCD to know about the fault, what the fault in this inverter. Okay, okay, soft start. Okay, we have unknown fault because we have not LCD in this inverter. So first I need to turn off this little switch. Okay, because the LCD panel is damaged. So the customer said just install a button for me to turn on the inverter and turn off the inverter. Just so I said yes, okay. And this is the inverter of my uncle, and now we need to deassemble this first. Okay, this is the VM3 5 kilowatt 48 volts. Okay, see the screws of this inverter, and first of all we need to remove this metal for this connector. First of all we need to remove this. Okay, so here we have two screws. Okay, and we can troubleshoot this fault without LCD. Okay, and now we need to remove this earth connection first. Remove carefully. Okay, don't touch the control drive card because here we have a little SMD components and sensitive components, so don't touch the control drive card. And this is the good thing, to first remove the control drive card in this deassembling time. This is the good thing because we can touch a screwdriver or we can touch any strip with this control drive card. So first we need to remove the control drive card and first we need to discharge. Okay, I turn on the switch and then water capacitors is Press charge. Okay, and now first of all we need to remove this control drive card for safety and attach the fingers here, this side and this side, not keep from these things. Okay, attach a finger like this and slowly pull up one side and other side. Okay, and you can remove easily and safely the control drive card, and after that you need to keep on the safe area. And now we don't need to more worry about the control drive card. And after that, here we have input line, brown color, worldwide system. Okay. So first we need to try with the gloves and fingers if possible. It's okay. And this is the input neutral. And after that, we need to remove the output line and output neutral. First we need to remove the output neutral. It's okay, and the output line will become, that's okay. And for good experience we need to remove this breaker, circuit breaker, to completely remove this metal piece. So you need to have a 14 mm wrench. Okay, this is the 14 mm nut. Okay, now I need to more turn with this. Okay, now I can remove this with just fingers because this is loose. It's okay, keep the nut in the box. And after that you can remove this completely, keep on the side. And after that we need to remove this air ventilation core first. Okay, so for this action you need to use this tool. This is the good tool to remove like this hooks. Oh man, expire hooks. It's okay. And how you can remove this, I am telling you how you can remove this from this heatsink. Okay, but first I need to remove this switch strip from here, and you can remove this with the angle tweezer like this. And after that we can remove our air ventilation core. Here you need to remove this. Here they're stuck. So first we need to free this because the air ventilation core is stuck with the heatsink. It's okay. On the side. And after that you need to remove the cooling fan strips carefully. If you have a glue and not removing the cooling fan strip, so you need to provide 150 degrees centigrade hot air to melt a glue just for 10 to 15 seconds, and after that you can remove easily. Okay, and after that you need to remove this PV positive and PV negative from here. First try with hand if possible, so you can. Okay, and after that we need to keep this strip safely here. Now we need to remove all the screws from board. Okay, but first you need to down your phone volume, multimedia volume, because I need to clean this with the air blower. Okay, and here are starting some noises. down your multimedia volume because I am cleaning this. Okay, I clean the inverter. And now we need to remove the main board from the body. Okay, so first we need to remove all the screw from this VM3 5000 watts. Okay, count the screws. 1, because you need to install these screws and right here. Okay, 1. First I need to provide some tape to write the screw quantities because I need to install again the screw quantities. I remove 1. Okay, 2, here we have 3rd, and this is the 4. Okay, number 4 screw, and this is the 5th. Here we have number 6. Okay, here we have 7. Number 8. Okay, 9. 10. 10. Okay, now I need to know about more. Here we have 1, 11. Okay, 11. 11. It's okay, remember this. Sorry. 11. Okay, and now I need to check. Okay, 11 screw I remove from this, and now I need to know about this center area, but we don't have any screw. Okay, so first you need to attach your fingers like this and try, but the board, yes, we have not any screw more, so we need to remove this wire. Cut this zip tie, but don't throw, keep in the box because this is the reminder to install again. Okay, when we troubleshoot this issue. 11 screws, anyone can comment. 11. Okay, 11 screws on PCB. It's okay. Now I need to remove remove carefully. Okay, now here we have this dust filter. Just fold this, okay, and remove like this carefully and easily. That's okay. Keep the body on the side. And now this is our VM3 5 kilowatt inverter. And the first one thing is that the capacitor has a D value. This is the first thing. Okay, remember this. Okay, and after that we need to check first of all our DC to DC boost section MOSFETs and control drive circuit, and how you can check the DC to DC boost section MOSFETs and control drive. Okay, I am sharing with you the method. First I need to set the board. That's okay, the true direction. And now keep, I can keep, okay, because I have no any metal on this side, and this is the rubber core, and I can keep this on this for you. Okay, so this is the pin number 1, 2, 3, and this 4 MOSFETs in parallel, again this 4 in parallel, again this 4 in parallel, and again this 4 in parallel, because this is the full bridge topology. You can call this topology because here we have a single transformer, and this is the full bridge topology. Okay, so first of all we need to check our DC to DC boost section MOSFETs. Pin 1 get, 2 drain, 3 source. Keep the negative on pin number 2 drain, and keep the positive on pin number 3 source. Okay, this 4 MOSFETs internal resistance is true. Now we need to check this another true resistance, and now we need to check this true resistance, and now we need to check this true resistance. After that we need to check this, and here we need to 500 and some continuity. Okay, depended on board designer. Okay, but this continuity is true. This is the transistor continuity. Okay, this drive is okay. We need to have same resistance. Okay, keep the positive on the source and negative on the gate 1. Okay, and now we need to check this. Okay, our DC to DC section is okay, and now we need to check our DC to AC converting IGBTs. Okay, so this is our DC to AC converting section. Okay, so first we need to check about this. This is the IGBT. Pin 1 get, 2 collector, 3 emitter. Okay, so keep the negative on the pin number 2 collector and positive on emitter, and check the resistance. This is the true resistance of this IGBT, and we need to have same resistance. That's okay, that's okay, that's okay, that's okay. Now we need to check this 4 IGBTs. That's okay, that's okay, that's okay, that's okay. Now, how we can troubleshoot this and what the issue? First of all, we need to check the bus of start voltages, okay, and provide a cooling fan. And I think maybe we have a fault in cooling fan. Checking the cooling fan. But first I need to provide a power supply and install a control drive card first, okay, and push down for from this area, okay, don't touch other components, that's okay, just for temporary. Oh, my crocodile crank is damaged. First I need to remove this nuts. Oh, this is the little capacitor charge, don't worry about the spark. Now I need to decrease my power supply for soft start, don't spark. It's okay. Positive. And this is the negative. And now I need to install a cooling fan. External cooling fan, just for feedback. Okay. Now I need to increase my power supply for soft start, the DC capacitors, okay, to keep safe the board from sparks. And now I need to install a button here, a manual button, my button, okay, and turn on. It's okay, the beep sound we have. And after that, oh man, before the soft start, okay. Now I need to decrease again my voltages. I forget this strip, okay, but don't worry, it does not matter, that's okay. Now I need to increase again my voltages. And turn on again, it's okay. First we need to soft start. The soft start consumption is okay, but we have an issue. So how we can troubleshoot this? Now we need to first check the DC soft start voltages, and first I need to keep the board on this side, and I need to install this protections PCB. Okay. First of all, we need to have here with soft start 380 volts DC. First, this is the first thing we need to have here, okay, because we need to know about what the soft start, okay, 20 volts. Now I need to keep the probes with true continuity, and after that I need to turn on the inverter and check here the voltages. Let's check soft start voltages. First we need to have, okay, this is the soft start voltages. The soft start is okay for this inverter, okay, and after that we need to check the negative voltages for this inverter without LCD. So first we need to know about where install the negative voltage regulator L712 negative voltage regulator. Okay. First I need to know about this thing. searching from this side with the help of a heat sink. But first I need to decrease my voltages again and turn on the inverter to consume the charge, the store charge in the capacitors. That's okay. I discharge the capacitors with the help of switch, and now I need to know about where install our negative voltage regulator L712. This is okay. This is our negative voltage regulator, and I am telling about this component, what the working of this voltage regulator. First we need to know about the pin number 1. So we have a pin number 1 on this side, okay, on this side. That's okay. And now I need to increase my power supply again. I think we have this fault 51. The fault 51 is completely related with this negative voltage regulator. Okay, so first up all we need to turn on our inverter. Okay, and after that this is the fin 1. So the fin 1 is positive GND. Okay, and here we need to have 14 to 16 volts DC. Okay, 13.67, and here we need to have 12 fixed 12 voltages. Okay, so here we have 11.99. This means we have little 10 millivolts. Okay, it's okay. And after that, what the issue we have in this inverter, we need to check. Okay, after that we need to check the voltages on this HCPL at 350. Okay, so I am turning on again this inverter, and I need to check the voltages on this autocoupler. This is the pin number 1, 2, 3, 4, 5, 6, 7, 8. The pin number 5 is a negative of this optocoupler driver HCPL 8350. Okay, that's okay. The true voltages we have on this, the true voltages we have on this, the true voltages we have, the true voltages. Okay, okay, we have true voltages. And first I need to keep silence this buzzer with some tape to decrease the sound. Not, we cannot completely silent, but we can silence this with some tape, because this is the very high frequency sound, and this is very bad for brains, for brain. So first I need to decrease my power supply again, and now I need to install temporary, and I need to push. Okay. And we need to know about the cooling fan. Cooling fan are the both cooling fan are running, or one running and one not running. So after that I need to increase again my power supply. That's okay. And now I need to turn on and know about the cooling fan. This cooling fan is working. This is working. The soft start is working. Again we have a fault. So after that we need to know about some drive voltages, PWM voltages. Okay, why we have an issue in this inverter. So first of all you need to know about this voltages, you need to keep the multimeter negative probe on the IGBT pin number 3 emitter, and you need to keep the positive on the pin number 1 gate, and after that you need to turn on the inverter. Okay, first we need to have negative 5 point some volts, it's okay, and after that we need to have positive. Okay, but for some I think I not received proper voltages to run the IGBT, but we need to know about more. It's okay. Now we need to confirm from this, and after that we need to know about with the oscilloscope. Okay, we have a negative voltages. Okay, no any positive voltages I receive to run the IGBT. Why man? Why you not turning on? Okay, turn on. I think this is little hard without LCD. What the fault we have? Because our bus soft start is okay and our cooling fan is running, but we are not receiving the positive voltages to run this IGBTs. Okay, now I need to turn on again. No. Okay. We need to have LCD, but what we can do for this situation, because we don't know about the fault. This is the artificial intelligent thing, so I need to install. Okay, I have some. You can install another model LCD. Okay, first we need to know about this. What's the fault? I think we have. Okay, first thing first. Another thing without LCD. First we need to try this without LCD. So here we have a D value capacitor. So we need to know about the voltages on this capacitor. First I need to know about where is the capacitor. Okay, this is I know about, and now I need to turn on again. Turn on again. Okay, increase voltages again. It's okay. Turn on, and here we have a faulty RD value capacitor. 14 voltages, and here 11.9. So this is far. Okay, here we have one another capacitor, 4.9 volts per L7805. So I need to install LCD finally, because our everything is okay. Then why we have a fault? Our bus start voltage is true, and our IGBT is true, and then why we have a fault? You can install this. This is another model, but I think this is the same card. Okay, I need to install this and check, and I am responsible for all my action and all the reactions for this action. Okay, I am responsible. If I lost anything, I can pay. No. Okay, I need HP power to provide a power for this insulating. No, no any display. Okay. Remove the power. Now we need check everything. Why? This LCD is not working in this model. First, we need to replace this capacitor first. Okay, first I need to discharge the capacitors because we have unknown fault. And the one thing after this I can forget. So first I need to check the NTCs. This is the 10 kilo ohm HDR, heat dependent resistor. Oh, the weather is very cold here. It's okay. And another, we have a 25 kilo ohm resistance of this NPC. And now we need to check this. Okay, it's mean our NTC or HDR is okay. And now we need to replace this capacitor. This capacitor is 2D value and this is 2D value, and I hope or I think here we have not enough voltages. First I need to know about the cooling fan voltages. Oh man, sorry, I don't decrease my power supply. So okay, how much voltage is coming for this cooling fan? Okay, this is the one. Okay, 7 volts. It's okay. And for this we need to have same voltages. Come on, man. I have issue in my button. Or what the issue? Okay, I'm shunting this button strip. Okay, 7 voltages. Let's check, man. Why? Okay. First I need to replace the capacitors. I think this is the fault 51, because everything is fine, then why bus start voltage is enough. First I need to discharge the capacitor. It's okay. Now I need to replace these two capacitors. Let's check about this. Okay, there's two. Okay, and the first one, yes. The second one, okay, I note this. But I need to connect the charger to my tablet to one for reading the comments, to view this live stream on another device. Okay, now I need to remove this capacitor first. Now I need to know about the capacity of this. How much capacity we have in this capacitor? $547 UF, and the capacitor is 1000 UF and 16 volts. So first I need to install this. Thousand UF and 16 volts. First I need to install this. But the difficult thing is that we have no LCD, and if I can't repair this, so we need to order the LCD or wait for other LCD to check about the fault. What the fault are detecting the MCU microcontroller? What fault detecting? Because or everything is fine, or IGBT is fine, or bus start voltage is okay, then why this is the difficult thing. That's okay. And this is the VM3 latest model. Okay, now I need to cut the extra pins. Okay, and now I need to replace this another one. Why always this capacitor is devaluing from heat reason? Oh man, that's a little difficult. It's okay. Now I need to clean the solder masks. I need to provide some more solder here. Not working. That's okay, fine. And now I need to install another 1000 UF here. It's 1000 UF. Okay. Why the area is little polarity. Okay. Yes, polarity. Little bend this to don't fall down. That's okay. Solder. It's okay. And now I need to cut the extra pins and clean this. It's okay. Now I need to check again. The board is very heavy. Oh man, remove this. It's okay. Install cooling fan again. And we cannot install another general common LCD because we have no strip area for this to install another type LCD. Now I need to decrease. Capacitors. I need to install this isolator here first. Don't spark. Okay. Increase. Okay. Now check. We have a fault still. Okay, but now the bus stop start is not working. Like click sound first for relay. We have a quick fault now. The MCU are detecting the fault very quickly. Now I need to decrease again the voltages and turn on to discharge the capacitors and tight a screw on this. And again I need to check. this is our unluck, we don't have LCD. Okay, now I need to increase again the voltages and check. Okay, bus stop start. Yes, the inverter is now okay. So the fault we was had with the devalued capacitors. Okay, and this is the output line or neutral, or this is the output neutral or line, as you can see. Okay, and reverse the polarity. So in my mind, the fault is that the fault was that fault 51. Okay, fault 51 or fault 57 current sensor fails because we have a capacity and one capacitor. How much capacity we have in this, we need to check again. 492 UF, and the capacitor was installed 1000 UF and 16 volts, and this is the second devalue capacitor. Oh man, so the full reason is that the 1000 UF capacitor is down to 20 UF. Wow, so the main reason was that. Okay, and after that I need to repair this another guy, and we have issue. This is the model name. First you need to SM-R4M IV 3.2 kV. Oh man, this is completely different, but the model is that Solar Max. After this we need to deassemble first, and if today possible I need to work on this and grow what I was installed today and go in the mountains. Okay, now I need to remove this, but first I need to check the PV voltages, and I need to receive PV voltages, and first we need to turn off to completely shut down our inverter, and after that we need to install a PV voltages. Okay, this is our PV negative and this is our PV positive, and I need to provide a power. Okay, the inverter sends the PV, and first we need to know about, okay, why I think the wires is disconnected, and first I need to attach something with this wire. Okay, it's okay. And how much voltages I provide? Oh, charging voltages. Okay, when I remove, now you need to check this. Okay, first we was had 50 voltages, and when I provide a PV, okay, and after that we need to have 56 point some volts, and I need to connect the charger with my phone. here we have our true voltages. That's mean our PV voltages is working. It's okay. And now I need to connect the charger with my phone. Okay, I connected. And now we need to wake up our system with a utility, because this is the important thing when you provide and this is the without battery system. So first I need to remove this, and I need to wake up this system without battery, because this is the without battery system VM3. So this is the important thing. And sometime we have a issue in or this area. So when your inverter shut down consuming battery, and after that you have a hang issue in your inverter. So first you need to wake up your inverter with the electricity without battery. This is the important thing, okay, to check and for better repairing. So first I'm providing to check the system, and this is not the good thing to install here. To install the proper connector for here, and now I need to wake up my system without battery. Okay, now I am connecting this with electricity. Okay, our inverter is a wake up. It's mean our wake up system is okay. What the wake up system? The wake up system is that when we apply a little, I need to guide you. When we apply AC voltages like 220, and we need to receive a 167 volt DC, okay, with from this transformer. Okay, so this transformer is installed for wake up this system without battery. Okay, now we need to assemble this first, and how you can assemble, if you know about, so you need to watch this, how you can assemble this. First I need to remove my cooling fan. Okay, and after that you need to discharge your DC to DC capacitors. Okay, I shunt this, I have already discharged, and after that you need to discharge this 450 volts capacitors, because we need to assemble this. So you need to check about the voltages, how many voltages you have in your 450 volts capacitor. Okay, here we have a 9 volts, but this is the good thing to discharge with some resistance. It's okay with some resistance, it's okay. Now we need to know about how many voltages we have. Okay, 0.4, it's okay. And now we need to just quick assemble in the body. Okay, now we need to install like previous remaining. Keep like this. This thing is not good. That's okay. Now I need to fold this air dust filter, and now I need to set the position. I need to keep this something like this. My JBL Go. Oh man, hold for me, please. No. Okay, now I need to provide some more thing to attach. Okay, this one cooling fan I need to keep here, and one another to keep this just for me. That's okay. Now I need to install the 11 screws on this board, and if we found more, so we need to install more screws if possible. Count. Okay, first you need to just little install. Okay, don't tight. 1 2 3 4 5 6 7 8 9 10 11. Okay, and now I have to install 12, so I found, and here we need to 13. That's okay, this is the good thing, because we have no any more screw to install on this board, so I need to add more 2 screws on this. This is the good thing. One, I need to install this, the 12. Okay, 12 or 13. Oh man, I need to don't talk and counting time. Okay, because I also forgetting the counting. It does not matter. Okay, now I need to install where. Okay, here. Yeah, I need to install one more screw, and I am counting now and tightening from this. Okay, 1 2 3 4 5 6 7 8 9 10 11 12. I add one more screw. Yes, and this is the 13, so this is the meaning. We remove one like this screw from body, so now the 13 screw I tied. This is okay. I think I got The counting system is now start. Okay. Before this, I was no knowledge about the counting, and the counting is good thing. First, you need to count the screws. Okay. For this reason, for doubts. Now, no any screws we have in this box. So first, I need to set this dust filter. Oh man, what we can do with this now? Okay. That's okay. It's okay. And now I need to install this, but first you need to little push this for good connection. Okay. PV positive. Okay. PV negative. And why I am saying don't through this, because this is the reminder to install here. Okay, I need to try on this side. No, this is not the good designing also. It's okay. Now cooling fan strips. Okay, and I need to turn on my tablet just. It's okay, turn on. And now I need to set this strips here, and I need to bind this with the zip tie, because this wire is going here, and I need to bind this with this cooling fan. To don't come here. This is not the good engineering who designed this body and board. Okay, and first we need to install air ventilation core. And now I need to install this strip first, this switch strip first, because when we tight, okay, but first we need to remove this hook from this heatsink. And how you can remove, I told you in yesterday live, you need to have a sharp head screw or self drilling screw. First I need to get one screw. The one method is that you drill this I am trying with this screw, but I think this is a little big screw. little come, but not completely. Now some particles come, but I need to try with the little thin screw, and I need to keep a special screw for this because this is anytime we can broke this. So now I need to try with some thin screw, and after that I need to remove this. Okay, I received some more piece. Now I need to tie it again. Okay, now we can install new, or we can install a screw. Okay, now I need to install this strap. First I need to attach this switch strap first, and this area is little difficult to install this ventilation core, because now I need to remove this JBL go. Okay, and now you need to little bend this air ventilation core, okay, with tweezer or other tools. Okay, and after that you can install properly. Now I need to stand up on this section, and I need to remove this zip tie again, because the air ventilation core is not good. Okay, we have just two hooks. Okay, and the one I need to install here. It's okay. And here we broke this hook, so I need to get one hook more for this, and I need to write down these hooks. I need to purchase this plastic hook, plastic hooks. Okay, I write down, and I need to order this for next time. Now if I have, I need to install, and I don't have, so I need to install a screw on this. The screw is good thing to install on this thing. This is not the working of plastic material, man. This screw is not good for this. This is good or not? Yes, this is good for this. It's okay. We have a lot of area. Okay. Now we need to install a this thing, but first we need to care about the control drive card. It's okay, and I need to set this and provide a nut to don't remove. Okay. And now it's okay. to install a screw. That's okay. It's okay. I need to install on this side. It's okay. Now I need to install input line and input neutral, and it's a little hard to install because this is the dip area, this is the output, and this is the input. So first I need to install this input line brown, tight, okay, and input neutral blue, okay, tight, and I need to install. Okay, here we have one connector here, and the second is here. Oh man, but first I need to know about this is the output neutral, okay, but first I need to install the line here in this dip area. Oh man, this is very hard to install, but you can install this with angle user, okay, like this. Okay, I install the line, and now I need to install this neutral for output neutral, and this is the blue wire, and you need to install for neutral, and I need the good thing is that for the straight user, it's okay. Install dip area, that's okay, tight, and I need to check it's okay, tight. And now we have a nut for breaker, circuit breaker, okay, now I need to tie this. I think this is the 14 mm, yeah, and this is the good thing to tie it with this, just with fingers, okay, not with the handle. Enough. Okay, I need to install a core, and we have no any LCD, and I need to order the LCD for this model, and now I need to remove this tab. Okay. Solar and water, and now I need to check this. Decrease the power, and for one reason I need to provide some glue, okay, like a previous now, sorry, not previous, some days ago we lost this, and we create our Mac again in very long time, so I need to provide this with something. here to don't fall again. This is the cementing glue, okay, not a super glue. It's okay. This is enough to don't fall down again for next time. It's okay. First I need to turn up. Let's check the button. The switch. And I install this, okay, because this is the inverter of my uncle. Okay, now I need to turn on like old halogen bulb on. Yeah. Now I need to check the output voltages. Battery low warning, no any fault. Okay, okay, I increase the voltages. Battery low warning, yes. Now I need to check the output voltages. 231. Reverse the polarity for pure AC. 231 watts. Okay. Now again I need to provide power, but I need. Okay. So now I need to turn off the inverter. That's okay. Remove the power. I am coming back live again with another video title. I mean, I need to little of this. No. I need to keep something for this white core. That's okay. Now I can install. Put here on the screw. Okay, here. Now I can install easily. That's okay. I think I do a mistake. What? First I need to know about this thing. What? Well, what is this? Okay. Let's check. Just for air ventilation. It's okay. To tight this on time. That's okay. One thing more. Connect the nuts. And you need to little tight, okay? Because area. It's okay. It's okay. Now what about this? So now I need to bind this. Man, this thing is not good. So I need to create a hole, but this is the company mistake, not my fault. So I need to set down this here. What the result? Yeah, it's okay. But now I need to check because I apply a force to set down the wires. So now I need to check. This is my duty. Okay, down the voltage. Then I need to replace my this crocodile clamps. I purchase and I need to replace. Oh, okay, turn on. Okay, sharp start. Okay, okay, battery low. Okay, I increase the voltages. That's okay. Then motor is fine. Turn off again. Okay, remove the power and close this. Okay, oh, this is just the empty box. Now I need to tie this with this. That's okay. That's done. Why? I need to install a screw, but we have no area for this, and this topic is closed. And now, what your feedback for this? I need to repair this in this live stream, or I need to come live again with this special title for this. So I need to come live again with this title. Okay, so I am coming back. Okay, take care and see you again with another video title. And first I need to find my this live stream, and if I end when I end this live stream, can I watch the previous live or this, because some viewer are come now. So first I need, to watch this video. Okay, and I need to backward. Okay, so if you need to watch this, so you need to reverse the video. Okay, you need to reverse the video, and I am ending this live. Okay, bye, take care, and coming live again with another video title.